Hey guys, welcome to this week's training. Today we want to take a look at testing our software and how we can use unit tests to make sure that the code that we write works the way that it's supposed to work and provides the correct results. So this will be the first video where we'll look at actually source code. Before we've gone over other skills. Some were soft skills and some were general training skills, like how to prepare for interviews and how to get ready to get your software engineering skills in a place where you can start earning income with them. But today we'll dive into a programming language and explore some real-world solution. Even though the code that we'll work with, it's fairly simple, of course. We want to keep this entry level so everyone can understand what's going on and get started quickly. So what I'm looking at here is a development environment called IntelliJ IDEA. So if you don't have that installed on your machine yet, I recommend that you download that. Just type it into Google, IntelliJ IDEA, and download the community edition, which is free. So again, that's the community edition. With that one, once you've downloaded it, you want to install a plugin for the Scala programming language, Scala. Make sure you install that one. And once you have those two things in place, you should be able to follow this little tutorial and create your first project with a unit test. All right, let's get started here. I'm going to create a new project so you can see all of the steps from the beginning. I'm clicking on File and then New and then Project. And the type of project that I want to select is Scala, and then on the right side we'll select an SPT as the project type. On the left side you see all kinds of programming language options that are currently installed in the development environment that I have here. For your personal case, you may not see all of these options. But the most important one we want to focus on today is the Scala programming language here, which requires that the Scala plugin is installed in your IDE. If this one's missing, that's the step you need to complete first. Make sure you add that plugin, and then you can get started with your first project. Okay, so I select SPT here and then click on Next. It will ask me for a project name. I'm going to call my project Calculator 1. And if you don't have a Java development kit installed, you may have to do that first by clicking on New, but in most cases you should have that. And I recommend you use version 1.8 or greater. And for the other options here, I accept the default values. You should be fine with that. And then I just click on Finish. It will set up the new environment for me. This might take a minute as it downloads all the dependencies and make sure you have everything required to build your project and run the code in it. So while it's doing that, I want to share a little bit about the importance of making your source code testable and also thinking about how to test it very early in the lifetime of your project or task that you're working on. Because if you design your code in a way that it is easily testable, you'll save yourself a lot of time later on, and it makes your code easier to maintain and change later as your service gets new features that need to be added, service or application, and that way you have a solution that's truly scalable and in a good place. And you can make sure that it's producing the correct results. So it opened for me something called the project browser here, once it initialized everything properly. And if it didn't do that in your case, just click on the project bar on the left area here and you should see the same thing. Then you can expand your project, the Calculator 1. And we navigate to the source folder with the src source cut. And it has these two subfolders, a main folder with a Scala folder in it and a test folder. And these two things are the key building blocks for your first application or first service that you're building. So the Scala, the source main Scala directory will contain the actual source code of your application, and the source test Scala 1 will contain your unit tests once you create them. So let's start with the source code first. In this case, we'll create our first class here. So I right click the directory and then select new and Scala class. And I'm going to give this a name. I'm going to create a class, our calculator. And in our case, I know that I'll only need one instance of this class and the application. So instead of just keep staying with class, I choose object, which guarantees that my class will only have a single instance and the whole application. And that makes it easier to access and easier to work with if you have a more simple use case, or if you use a more functional approach, which is something that I would recommend. At least as a baseline. Of course, you can always extend it later, and for some cases you will need classes, but in our case it's simple enough. Let's go with an object. So I will double click this, and then I will create my object. Source code looks fairly simple, right? It just has the object keyword and then the name of the object that we're creating and a block for the code where we want to define the behavior of this object. And next I'm going to create a function inside of this new calculator object. You create functions in Scala with the def keyword followed by the name of the function. And I want to create a function here that can calculate the absolute distance between two numeric values. And these will be integer values, so we don't have to worry about fractions for this one, just whole integers. So I'm going to call the function absolute distance. Okay, now that we have defined the function, we want to also define the parameters in it, and you do that with the parentheses in Scala. And then our first parameter, we'll just name it x, keep it simple. That's the name of it, and followed by the type of the parameter. Scala is a type-safe language, so whenever you define variables or parameters for functions, need to make sure you also define the type. That's different from Python, where it will infer the type from the context. It also support multiple types and many use cases. So in this case, we will do the type explicitly and define it here. And a second parameter, since we need to have a way to calculate the distance, we need a second one. We'll just call y for simplicity and use the same type. And then we'll start defining the body for a function. So to calculate the distance, let's keep it simple for now. That should work by just subtracting y from x, right? And in Scala, you can keep things pretty simple. You don't have to define a block of code if it's just a single line function. It's a fairly simple one. And this is valid syntax. Whenever somebody calls this function absolute distance and passes these two parameters, we will perform this calculation on the right and returning the result of that calculation to the caller of the function. And you see that the IDE marked something in light gray here, which lets us know that it wants to have a return type for this function, which is defined with a colon after the parameter list, and then we give the right type. In this case, our compiler could guess what the type should be, and it already displayed it to us. So I just wrote it in so it's clearly defined and other people can see it when they call the function. Okay, and that should be it for the start of our code here. Let's go to the next level and create a unit test for this new calculator object that we have created. For that, I will right click on my source test Scala directory and select new Scala class for that one. And test cases in Scala, they are oftentimes called a specification or a spec. So I call this one a calculator spec, where we define the expected behavior of the calculator object. Okay, you might wonder, okay, should I use a class or an object? But for a unit test, it's actually good to use a class since it uses inheritance, and we use a unit test base class. and there could actually be multiple instances of your test class. So let's go with the class for that one. Double click that. And to run this test case efficiently and with the right support from the IDE, we want to add a little tool to our project here, which is called Scala test. And in order to do that, we have to add it to a build file, which is located here in the main directory of our project. It's called build.sbt. SBT stands for Scala Build Tool. And you see some different variables defined here, the name of our project, the version of it, and then the Scala version we're using. And here we want to add the Scala test library so we can use it for a unit test. And let's assume I don't remember how to add that, because it can be a little complicated to get all these details right? So one thing that a developer uses a lot in addition to the Stack Overflow website is Google. So I'm switching to my web browser here. And I'm going to Google how to do that, right? So I'll say SBT add Scala test. Yeah, that seems like a good idea. See what kind of results we get. The first one is usually helpful. It looks good. It's from scalatest.org. Let's click on that one. Okay, and then it tells us here what we need to add to our build file in order to add that library so we can use it in our test cases. I'm just going to copy and paste this code and see if it works. And append it to the end of my build.sbt file. It's good to have a new line at the end of your line, so if you commit it to version control later, then if you change this line, it doesn't affect anything that's below it. Okay. Or if you add new lines after this, it wouldn't include this line as a line that was changed. So it's actually a good benefit later on. Now that we have added this, the IDE notices that something has changed, and it asks us if we want to import our changes into the project. So I'm going to say yes to that. Let's import what we just added here and make sure the library is actually downloaded and added to our project so we can use it successfully when we run our test cases. This will probably take another minute. While it does that, let's review the structure of our project real quick. So we have the calculator class in our source main Scala directory, calculator spec, and source test Scala. And that's ready to rock and roll once we have the library added by SBT, which we're really close to have done. So let's go to our spec and start making it ready here. So we'll extend a base class that's provided by Scala test, and the one that we want to use, it's called any flat spec. Extend is not correct. We need the S here. Okay, and once we have that syntax correct, it will ask us to import that class. So it found it in the library and gives us the option to import it. So I'm going to do that, and then it adds this little import line here at the top, which means it imports something from a library that we added in the SBT file just a moment ago. And with the extend keyword, I say that my class calculator spec will have all the functionality of any flat spec. And in addition, we'll define some more logic down here in the body of the class. But let's do that first. And I know that I also want something else which is useful for test cases. I'll also add support for matchers. I'll explain in a minute what that is. It gives me a suggestion for what kind of matcher to use. I'll just go with the first option here. That's another import. That looks good. So now let's define the expected behavior for calculator class. Calculator should return the distance of two integers. So we're going to say in, and then we can define a block of code. So this is something that's pretty nice about Scala test. The way it defines specifications, You can write them very much like a sentence in English. You just have to use these quotes to identify strings. So we have a name for the thing that we are testing on the left, and then we use the should keyword and the behavior that's expected. Also another string where we just describe in free text what it's supposed to do. And this also serves, of course, as documentation of the right behavior of the class that we're testing. Great, now let's write some code that will confirm that our calculator object works as expected. I'm going to call the function calculator.absolute distance. So the IDE helps me a lot. It auto-completes what I'm most likely to type. And now it shows me that it expects two integer values, the x and the y parameters. So we're going to keep it simple here. Let's say we want to calculate the distance between 3 and 1. And the result should be 2, if everything works correctly, doesn't it? Okay, so that looks right from the syntax. And now if I want to run this test case, the IDE recognized that this is a little function that we have in our calculator spec class and gives me the option to run it here by clicking on the green icon, run test. I'm going to choose the first option. And when I do that, SPT will build my test class. And if it hasn't been built already, it will also build my calculator object and run the test case against it and see if everything passes. All right, looks like we have things running now. Let's see what the result will be. Looks like our test passed. We have one successfully passed test. And on the left side, you see that it tested the calculator object, made sure that it returns the distance of two integers, and that was successful. Returned that in 392 milliseconds. That seems a little bit slow. I think we can do faster than that, but it's a good start. All right. So let's see if it also handles some other options that somebody might want to use to calculate a distance. Calculator, absolute distance. Let's see if it can do the reverse, right? Calculate the distance between 1 and 3. That should also be 2 if everything works correctly. Let's run this again. This one might be a little faster because we only updated the test case and everything else is already in the cache. Yeah, we get a result pretty quick. Oh, but it failed. So the result that it returned was -2, and we are expecting the result 2. So that actually indicates a little problem in our implementation of the calculator function. Let's go back to that. So we said to calculate the absolute distance, we will just subtract y from x. And in this case, the numbers that come in are, let's confirm what they were. They are 1 and 3. So x will have the value 1, y will have the value 3. So we subtract the number 3 from the number 1, and that of course will return the negative value of 2, or minus 2 rather. So that's not accurate. Let's see if we can extend that a little bit. And to fix this, of course, we could use the math.absolute function, keep it simple, but let's say we might extend this later and have a custom number type that needs some proper logic or some custom implementation of this function. So we cannot go with the library function that Scala provides here. We have to write that manually, and we just write the framework for that now. Let's say we add a little check here. If x is smaller than y, then if it's smaller, then we will have to subtract x from y, right? So subtract x from y, and else we can keep it as it is, subtract y from x. That seems like it should work. Let's see if our test case is happy with that. Switch back to it and run it again. And in a few moments we will know if this is successful or not. Great, test passed. Nice. Now let's be creative and add a few more test cases. Make sure that in addition to positive numbers, it can also handle negative numbers well. Let's say we have the number 3 and the number -1, that the absolute distance of those two should be 4. And then we also want to make sure that it can handle two negative values properly. If we have -4 and -7, for example, let's do -2, so we have the different direction because we're going down here in the function above and now we're going up in the numeric value. This way that should also work properly. The result of that should be 2. That's a pretty good test case, and I can think of one more. How about we have two identical values and calculate the distance of them, because that can also happen in a source code, right? If values are being assigned, potentially anything could be in there. I need to make sure it returns a proper result of 0 for that case. Okay, I think this is a pretty exhaustive list of test cases. Maybe you can think of more options, use some really large numbers maybe, but this should be good for the basic things that could happen here and could be used in calling this function. Let's run our test case again. See if we can cover all of these tests successfully or if we get any error messages. Oh, that looks great. I was able to successfully test all of our logic, and we also see the time it took to run the test went down a little bit. It's now only 80 milliseconds because everything is in the cache and things run a little faster that way. Nice. So this concludes our little session of writing unit tests. And as I mentioned in the beginning, having a unit test is really great as your software grows to help you maintain it, make sure you have the right expected results for all the functions of the code that you build. And of course, with this very simple example, it may not be as useful yet, but the larger your code base grows, the more impactful it will be to have these unit tests. So I would encourage you to create them as early as possible. There's even a approach called test-driven development that recommends people to write the unit tests before they write the actual implementation. And that's a really useful approach. I recommend that you experiment with that one at least once or twice and see how you like it. So with that one, you would basically write what we did second here first. You would write your unit test first, describe all the expected behavior. You think about what kind of functions your code will need and then how it would be called. And you can actually oftentimes derive the specification, this unit test, from the requirements that you get from your stakeholders. So you should have those first before you write any code, and then you can make sure everything is covered that are the key requirements before you move forward and write the actual implementation. Thank you so much for joining this training session, and I hope you have a great time implementing this in your day-to-day code.